All right, this is a walkthrough of the Zoom setup for this presentation. So we'll go here and go to share screen and advanced sharing options. So I want to share my screen, but I want to share a specific portion of the screen. So click share screen, and I'm going to adjust this to only this presentation here. There we go. Okay. So now I'll do a presentation on the word match generator. Okay. Thank you for the opportunity to present my research. I'm going to go ahead and hit reset here. Thank you for the opportunity to present my research. I am specifically grateful for the guidance of Dr. Leong. My name is Evan Gertis. In this presentation, we will discuss the design and implementation of an automatic word match generator. An automatic word match generator is a software tool that can be used to generate word matching interactives automatically. The purpose of a word matching interactive is to provide students with a mechanism to learn new vocabulary and improve their reading comprehension skills. This thesis will present the design and implementation of an automatic word match generator, as well as the research and algorithms used in the program. In this presentation, we will review the literature supporting our research, the problem and motivation behind what we are doing, and the methodology that we followed. Then we will show the results of our efforts. So, the problem and motivation. Students tend to face difficulties when they are required to learn new terminology. For example, understanding how to differentiate between the terms hardware and software can be challenging for beginner computer science students. Word matching games have been used by instructors to teach vocabulary to students. Previous researchers, Arifa and Krishnamurthy in 2013, utilized a technique called Make-A-Match, which has been shown to be successful in teaching vocabulary and developing reading comprehension skills. This was originally introduced by Forma Karan in 1994. Riyadata Nikma and Hussein applied this concept with pictures in words. Also, a company called Fast Forward Products developed a set of software-based word matching games that were shown to help improve reading comprehension and vocabulary skills by the Brigance Comprehensive Inventory of Basic Skills. Google Trends also showed that there was a Udemy usage spike during March of 2020. This indicates that there was an uptick in the usage of online learning. And online learning platforms like Revel use interactives, which have been shown to help students improve their average quiz letter grades. So, a review of the literature. Figure 1 shows an example of Make-A-Match. Make-A-Match is an exercise where students match the words to pictures in this case. Forma Karan originally created the concept of Make-A-Match in 1994. Nikma and Hussein tested students' ability to match words and descriptions on cards. In their study, they split students into two groups and had them match different pairs of cards. Masari and Najjar used a variation of the technique, except theirs leveraged pictures and words. In both cases, the average post-test score in the experimental group was higher than the average post-test score in the control group. Nikma and Hussein's research revealed post-test scores of 80.40 for their experimental group and 77.20 for the control group. The measured p-value of the post-test score was less than the significance value of 0.05. The results of the two-tailed t-test for this study, with a degree of freedom of 29, was 19.282, which is greater than the t-value of 2.045, thus rejecting the null hypothesis and accepting the alternative hypothesis, therefore supporting the case that word-matching games like Make-A-Match help students improve their vocabulary and reading comprehension skills. Figure 2 demonstrates that students gained 3 and 1.5 years in reading grade level. Their average letter-word identification improved by 14 months. Their average gain on the passage comprehension subtest of the Woodcock-Johnson 3 tests of achievement was 2 years. Fast Forward Products took a previously successful concept, computer software that focuses on developing learning and cognitive skills, and improved upon it. They provided computer-based products that combined an optimal learning environment with a focus on early reading and cognitive skills. If you look at this graph right here, specifically at the red line indicator there with IDs, we can see that as students participate over time, the average percentage completion increases and eventually stabilizes, therefore supporting the case that the consistent practice of using these word matching games improves vocabulary and reading comprehension skills. This figure shows that there was a spike in Udemy usage during the pandemic. It is possible that this peak can be attributed to the forced isolation brought on by COVID-19. The consequences of the pandemic were unstoppable and uncontrollable for higher education industries, much like the rest of the world. Most higher education systems are now operating through e-learning platforms. It is possible that the stabilization of this curve implies that the world has adapted to the usage of online learning platforms like Udemy, Unacademy, Swayam, and edX. Our research will help students who are either studying or working remotely. So, Revel is a program used both at home and in class. It is an online learning platform. It provides students with a process for practicing what they've learned. Revel Interactives provide integrated live examples that help students improve retention of key programming concepts through the application of running and modifying live code. Figure 4 shows a strong correlation exists between the average Revel grade and the average quiz grade, where R, a statistical measure, measures the statistical difference between these two values, is 0.50 and P is 0.10. Figure 5 shows a relationship between the average exam grade, lab grade, and final course grade. It shows that the Revel grade is indicative of the relationship between these different grades. The higher the average exam grade, lab grade, and final grade, the higher the Revel grade. Figure 6 shows that a strong positive correlation exists between the average Revel grades and final course grades, where R is equal to 0.67 and P is less than 0.01. Figure 7 shows that the higher the average Revel grade, the higher the average Quizletter grade. Figure 8 shows that the average grade increased from 59% to 70% from spring of 2015 to fall of 2015 for students who used Revel. Figure 9 shows a t-test. A t-test measures whether the means of two groups are statistically significant. It measures whether they're statistically different. It shows that the average exam grades from spring of 2015 to fall of 2015 improved. The results of this t-test show that students in fall of 2015 with a mean of 70% scored higher on average exam grades than students in spring of 2015 with a mean of 59%, where we have a t with a degree of freedom of 118, a sample size of 118, and a p-value of 0.05, indicating that this increase was statistically significant. Now we will discuss the requirement specification. So, instructors shall be able to automatically create interactive word matching games. Students shall be able to access the games online. From a developer perspective, the following specifications were required: enable the storage and retrieval of word matching interactives, capture the input data necessary to create word matching interactives, provide a web interface for displaying word matching interactives, develop a drag and drop algorithm that facilitates an interactive learning experience using the derived data from the output. Figure 10 shows a before and after picture of the automatic word match generator. The implementation of the custom 3-tiered application that we designed was non-trivial. As you can see in the top left, we have a simple static HTML, CSS, JavaScript page. In the bottom, we have the custom multi-tiered application. This application presents a view to an instructor. That instructor can use that GUI to create a word matching interactive by typing in the key terms and descriptions. And then when they click the Generate HTML button, they're presented with the raw HTML for the word matching interactive. and then when they click post, it is sent to the server, as we can see by this diagram, moving from 1 to 2. A handler picks up the request. This handler processes the request and routes it to the right controller method. This controller method on the controller processes that request and then calls a service method. The service, which essentially processes all of the backend code, saves the word matching interactives on the file system. Then when the interaction is complete, a response is returned back to the controller. The controller returns the response back to the client. So the client to server interaction is simply a request going in and a request coming out. Once that's complete, the instructor receives a indicator by a button that says view. This view is associated to an ID. The ID is associated with a word matching interactive. The instructor can click the view button that will take them to the word matching interactive with the associated ID. They can pass this URL to a student, and then whenever a student visits that page, they can complete the word matching interactive. This interaction can be seen in steps 4 through 3. We can see how that request goes through and it's sent back to the controller, and then a view is presented back to the user. So, first we selected languages for developing the program. Java was selected based on both mine and Dr. Young's familiarity with Java. Then we identified the input and output, and then we implemented the functionality based on the requirement specification. We will discuss what a word matching interactive is in subsequent slides. So, algorithm design. The crux of this algorithm is the conditional comparison of the source index and the target index. Step 1, we obtain the index of the drag key term as a source index. Step 2, we obtain the index of the row where the key term was dropped as a target index. And then in step 3, we provide a comparison. We check to see if the source index is not equal to the target index. If so, we return the key term back to the key term pool. In step 4, we disable the key term object to be undraggable. In step 5, we set a new color for the matched row object. In step 6, we test if all key terms are matched. If so, we display a congratulations dialog. In step 7, we increase the success count by 1. Figure 12 shows Figure 11 shows the automatic word match generator UI for an instructor. Now this is what an instructor would see. They'll go ahead and type in their key terms and descriptions. Figure 12 shows the user interface after it has been pre-populated with key terms and descriptions. Figure 13 shows the automatic word match generator after clicking the Generate HTML button. Here we can see the HTML that is used specifically to create this word matching interactive. Figure 14 shows the automatic word match generator UI after clicking post. At this point, the word matching interactive has been saved onto the server. Figure 15 shows a word matching interactive that features key terms from Introduction to Java Programming. Now we'll discuss the main points of research that influenced our project. So, the basis of our research stemmed from generative programming and code generation. Generative programming is the application of reusing code for a new function or software. Code generation is a mechanism to produce the executable form of a program. We'll discuss automatic programming. A generic input can be applied to this process, then a web page output can be generated. In the case of the automatic word match generator, input is entered from the text fields and stored in arrays. Then validation checks if the key terms or their descriptions are empty. In process data, the data is shuffled randomly and key terms are mapped to descriptions. In step 4, Create Web Page is used to create HTML, CSS, and JavaScript to produce a word matching interactive. In step 5, we post the web page automatically to a generated web page on a web server so that the page can be viewed on the internet. In conclusion, word matching interactives provide students with the intent to improve their vocabulary and reading comprehension skills, as shown in the learning curve from Fast Forward products in Figure 4. Additionally, interactives have been shown to improve student performance on quizzes and tests as shown by the test results from Revel shown in figures 5 through 9. At this point, we'll go ahead and start a live demonstration. This appears to be unavailable. No worries, we'll go ahead and run a local version of this. We'll open up Visual Studio Code. Visual Studio Code contains all of the files necessary to run this program. We'll go ahead and go to the terminal here. I will start the project here by changing the Java version to Java 1.8 as seen in the user manual and instruction guide for the automatic word match generator. Now I'll run the program by running the command maven spring boot run. This indicates that the word match generator is up and running. We'll go ahead and go back to the browser. We'll go to localhost word match generator. We'll create a quiz here. Now we'll click Generate HTML. This generates the HTML for the word matching interactive. Now we'll click Save. We'll click View to see the word matching interactive. Now we'll drag the key terms to their descriptions. So we'll try to drag caballo, so donkey. That doesn't work. Burro, let's drag to donkey. This works. We'll go ahead and activate the speech synthesis, which will help students who struggle with reading what's on the screen. They can hear it.
Caballo, horse.
This shows that the interaction is complete. Click OK, click Reset, and show the answer. Burro, donkey, caballo, horse. Any questions? A quick search of other word matching interactives will reveal the Teacher's Corner. So the Teacher's Corner provides a matchup tool which isn't effective because it is covered in ads and it is frustrating to use. Just trying to type a key term and definition opens a tab. It's not made for instructors, it's a gimmick. So this shows a view of Teacher's Corner. It's a complicated website with a bunch of advertisements on it and it's quite distracting. Here we enter the same thing, a Spanish quiz and the purpose behind the quiz. Then we can enter the horse, donkey quiz that we just saw. When we try to generate it, the issue is when you actually type something in, an ad comes up, and this ad requires you to see that this has an open and close hamburger box on it. It's very distracting, not very helpful. This example here shows the usage of word matching interactives in Revel. Revel is a reputable online learning platform that has been proven to be successful in helping students develop their reading comprehension skills and their vocabulary. So, if there aren't any questions, thank you for your time and thank you for paying attention to this presentation. Okay, and that concludes the preparation for this presentation on how to present a comprehensive exam for a thesis. We can see that I'm under 20 minutes here, which is a good time, and I've gone through and I've prepared for the different types of questions I could possibly receive. So, yep, there we go.